Momentum is the product of an object's mass and speed. To best demonstrate momentum in action, we chose the sport football. We ran multiple trials involving the collision of two players, changing variables such as speed and mass with each trial. Before any trials could be run, we had to weigh both Avery and I. After converting from pounds to kilograms, Avery's weight came to about 74.8 kilograms, and I weighed in at 56.7 kilograms. Next, because one of our trials involved Avery running into me at his top speed, we measured his max velocity. We did this by using the slow motion feature on our phone. Because the phone records at 240 frames per second, we know that every frame equals roughly 0.004166 seconds. By going frame by frame, we can see that Avery crosses the 1 meter long stick in 29 frames. If I multiply 29 frames by 0.004166 seconds and put that number under 1 meter, we get his average velocity, which is about 8.3 meters per second. Now let's look at our video. In order to calculate the momentum of Avery, I have to have his mass and velocity. Here, I'm going to assume that Avery reached his max velocity by the time he collided with me. His velocity of 8.3 meters per second gets multiplied by his mass, 74.8 kilograms, resulting in a momentum of 620 kilograms times meters per second. I, on the other hand, have no momentum whatsoever. In order for momentum to exist, there must be some form of motion. Now, let's look at two identical forces acting in opposite directions. As you may know, adding two equal but opposite forces results in a net force of 0. Here, both Connor and I run at each other, albeit pretty pathetically. We are within 1 kilo of each other's weight and seem to run at similar speeds. Assuming we both hit each other at the same speed, say 2.0 meters per second, with Connor weighing 1 kilo less than me, we can calculate the net force of the collision. Once again, by multiplying the mass times velocity, we see that I had a momentum of 110 kilograms times meters per second, and Connor has a momentum of 110 kilograms times meters per second. The net of these two forces is 0, resulting in us stopping with no other motion. Some positions in football favor heavier players over stronger, more muscular players. For example, linemen in the NFL weigh more than they ever have, with the average lineman weighing 312 pounds for 2015. By weighing more, these players need less speed to achieve a high momentum. A player that weighs half of their opponent's weight would have to go twice as fast to have as much momentum. What you see here is Avery and I in a 3-point stance, ready to strike. Let's see what happens.
I'm ready.
Avery was able to easily push me back as he gained momentum much faster than me. Having the extra weight gives an enormous advantage when in this situation. In order for me to equal his momentum at 1 meter a second, I would have to be traveling at 1.3 meters per second, which is tough to achieve when so close to each other.